Hi, this is Nexus Innovate. Today, we'll explore how Russian aggression against Ukraine has driven the development of drones and other technologies. These systems are already changing the battlefield and will find applications in our daily lives in the future. You've seen drones on the news, but do you know exactly how they are changing the course of war and what this means for the future of technology? Aerial drones. Types and functions. Reconnaissance and target designation drones. Compact, equipped with powerful cameras and sensors, they collect real-time data on enemy positions. They transmit coordinates for artillery and missiles, enabling precise strikes with minimal collateral damage. Air defense drones. Intercept enemy drones or low-flying targets. They may use nets, explosives or jammers to protect friendly forces. Kamikaze drones. Single-use FPV drones with explosives, controlled by operators. They strike vehicles and fortifications, detonating on contact for maximum effect. Supply drones. Deliver ammunition, medical supplies or food to the front lines, avoiding enemy fire and rough terrain. Minefield mapping drones. Use LiDAR, radar and AI to scan terrain and create 3D maps of safe routes. Relay drones. Boost communication between troops and drones over long distances or in areas with interference. Mothership drones. Large drones that carry and deploy smaller UAVs, acting as mobile bases. Development forecast. Smaller drones will become fully autonomous, operating in swarms without human operators. Kamikaze drones will become more precise, with AI capable of prioritizing targets. Supply drones will carry heavier loads over longer distances. Hybrid models will emerge, combining reconnaissance, attack and logistics in a single device. Ground drones. Functions. Wheeled or tracked robots deliver ammunition, evacuate the wounded, and clear mines. Take on dangerous tasks, reducing human risk. Development forecast. Fully autonomous ground swarms for reconnaissance and logistics. Intelligent evacuation robots with AI that independently determine rescue priorities. Systems for rapid mine clearance and construction of temporary fortifications. Surface drones. Functions. Unmanned boats conduct reconnaissance, strike targets, and deliver cargo to shore. Transport aerial drones acting as mini aircraft carriers. Lower risk and cost compared to using conventional military vessels under fire. Development forecast. Autonomous surface swarms for river and sea patrols. Hybrid platforms combining transport, reconnaissance, and strike capabilities. Smaller, faster drones for covert operations. Underwater drones. Functions. Reconnaissance, mine detection, inspection of ports and pipelines. In the future, autonomous devices capable of operating underwater for weeks. Development forecast. Robots with fully autonomous navigation and AI for target search and data collection. Drones capable of constructing underwater infrastructure, pipelines, cables. Use in environmental monitoring and rescue operations. Local energy and drones. Types of local energy. Solar panels and mini solar power plants. Microturbines and gas generators, small-scale wind turbines, battery systems and energy storage units. Role of drones. Deliver and install equipment in hard-to-reach locations. Monitor the condition of panels, turbines and communication lines. Quickly detect damage after combat or natural disasters. Development forecast. Autonomous drones for maintenance and repair of energy facilities. Integration with AI to manage distributed energy networks. Coordination with surface and aerial platforms for energy delivery and remote monitoring. Satellite systems. Functions. GPS navigation for drones and military operations. Reconnaissance and monitoring of large territorial movements. Support for local energy through satellite observation and forecasting of energy production, solar and wind. Development forecast. More precise and secure satellite networks for drones and logistics. Automatic coordination of drone swarms via satellites. Use of satellites for infrastructure and environmental analysis. Drone shield and mass air defence. Threat relevance. In recent months, Europe has faced aggressive attacks and armed provocations involving drones, including incidents over Poland and the Baltic countries. Large numbers of cheap UAVs can quickly overcome traditional air defence systems and threaten cities, infrastructure, and local energy systems. Countermeasure layers. Soft kill. Jammers, nets, optical disorienters, inexpensive and deployable in large numbers, but vulnerable to protected channels. Kinetic. Cheap interceptors, small caliber guns, disposable net drones. Directed energy. Lasers and microwave systems for precise strikes against large drone swarms. AI and sensor networks. Radars. Optics, acoustics and AI for threat classification and prioritization. Maritime and coastal barriers. Autonomous surface platforms protecting coasts and key assets. Air defence and laser. Development forecast 1 to 2 years. Mass deployment of cheap jammers and kinetic interceptors 2 to 5 years. Integration of mobile medium-power lasers and automated AI coordination systems. 5 to 10 years. National shield networks with dense integration of sensors, lasers and AI, automatically countering swarms of cheap drones. Connection to local energy. Effective mass air defence requires continuous power supply, justifying local energy systems, autonomous microsolar plants, and battery storage to keep defence systems operational even when the main grid is disrupted. Why it matters. Russian aggression has accelerated technology development because drones make operations faster and safer, reduce losses and function even under electronic interference. Local energy systems and modern air defences create secure infrastructure and protect civilians. Risks: autonomous weapons, cyber attacks, loss of control. Preparing for new types of weapons and countermeasures is crucial today. Conclusion: war is a tragedy, but technologies developed on the front lines will be useful in civilian life. Rescue operations, cargo delivery, energy and industrial solutions, protection systems against mass unmanned aerial vehicles. Which drones or technologies do you think will change the future the fastest? Comment below. Subscribe to Nexus Innovate, like the video and stay updated. The technologies of the future are already here.